So how would you find out what the inverse of a matrix is? Well, we do know that from what we said above that a matrix times its inverse should be equal to the identity matrix. So I can actually write a matrix equation. I can say, well, matrix A, which is 1, 4, -1, -3, times matrix, the inverse of A, which I don't know what that is yet, should equal the identity matrix. And if this is a 2 by 2, matrix A is 2 by 2, its identity matrix is going to be 2 by 2. So the identity matrix would look like this. Since this is 2 by 2, and since this is 2 by 2, this would have to be a 2 to match up with that, and since the dimensions of this is 2 by 2, this needs to be a 2 as well. So our inverse has to be a 2 by 2. And remember, only square matrices will have inverses, and the inverses will actually have the same dimensions as the original. So keep that in mind. So we need to find out what these 4 entries are. We don't know what they are. We're going to give them unknowns, A, B, C, D. Just give them names, okay? They're unknowns, and we're going to try to find out what they are. All right. Well, based on matrix multiplication, I can actually extract some equations from this matrix equation, some real number equations. And I'm going to do it based on how matrix multiplication is defined. If this equation is true, that means that, for instance, if I want to get this number 1 here in that entry, that's the product of, or that's 1 times, that's the product of row 1 in the first matrix times column 1 in the second. So it'll be 1 times A plus 4 times C should equal 1. And I can write that equation. 1 times A plus 4 times C equal 1. And then to get this 0, I can do, that's row 1, column 2, so I can do row 1 here times column 2 there. 1 times B plus 4 times D and that should equal 0. Okay, and then to get this 0, I can, it's row 2, column 1, so I can do row 2 here times column 1 there. It'll be -A minus 3C equals 0. And finally, row 2, column 2, we can get from doing row 2 times column 2 here, -B minus 3D equals 0. Okay? But we have 4 unknowns, and we actually have 4 equations, so this is, we can solve this system. And they're actually grouped too. This, over on the left, we've got 2 equations with 2 unknowns, A and C, and on the right, we've got 2 equations with the 2 unknowns, B and D. And remember what we learned in 8.1 is we can take a system of equations and write it as an augmented matrix, and that's what I'm going to do here. I'm going to write this as the augmented matrix. There's our coefficient matrix on the left and a 1, 0 on the right. And then this one would, here's the coefficient matrix, look like this. And oops, I messed up here. What did I mess up on? The B, that should be a 1, not a 0. Whoops. Okay. Alright. Now, if you notice, these look very similar, the 2 augmented matrices. I've got the same exact coefficient matrix on the left, and then 1, 0 here and a 0, 1 here. What we're going to actually do is combine these 2. We're going to combine those 2 augmented matrices into a doubly augmented matrix. So we don't have to do, because solving this, remember, we would want to get it in reduced row echelon form. We'd want a 1 here, a 1 here, a 0 here, and a 0 there, right? But we'd do the same moves to get this one in that form as we would to get this one in that form. So instead of doing the same moves on two different augmented matrices, we're just going to make a doubly augmented matrix and just do one set of moves, if that makes any sense. So let me show you what I'm talking about. We're going to write this coefficient matrix just once. And on the other side, we've got our 1, 0 representing this column here, and then I'm going to represent that column with a 0, 1 here. Alright. And notice what's notice what we have on the right. That's the identity matrix, and on the left is actually our matrix A. Okay? That's our matrix A. Now to solve this, the goal is to get this in reduced row echelon form, and that would look like that on the left, and then on the right, we don't know what that's going to be, but that would actually be our solution. That would be A, B, C, and D. In other words, that would be our inverse. And on the left, that's actually the identity matrix, right? So if we're trying to, the method here is if we're trying to find the inverse of a matrix A, we write it in an augmented matrix, a doubly augmented matrix, with the matrix on the left, the identity matrix on the right. Then we're going to use row operations in order to get it in reduced row echelon form. In other words, get the identity matrix on the left, and what will pop up on the right, conveniently, is the inverse of A. Okay? Let me see if we can do this. Okay, 1, 4, negative 1, negative 3. Alright, so we've got 1, 4, negative 1, negative 3. That's our matrix A on the left. Here's the identity matrix on the right. I want to get it again. I want to get it in reduced row echelon form. I want my identity matrix on the left. So start with this 1. If that wasn't a 1, we would do a row operation, but to change that. But it is a 1, so we can leave that. Then we go to row 2 with our negative 1 here. We want to get rid of that, and the best way to do that is to add row 1 and row 2 and make that our new row 2. Okay. So my row 1 stays the same. It's 1, 4, 1, 0, and negative 1, negative 3, 0, 1. Oh, I'm sorry. The first row stays the same. The second row does not. I just rewrote that. Let's see. Erase. Okay. Second row should be 0, 1, 1, 1, right? I just added row 1 and row 2. That's my new row 2. So now this is a 0. That's what I wanted, and that's a 1, conveniently enough. So that's what I wanted also. Now I need to take care of this. That needs to be a 0 instead of a 4. And I'm going to use that 1 to make that a 0. So I'm going to do negative 4 times row 2 plus row 1. It's going to be row 1. So let's see. Negative 4 times row 2 is 0, negative 4, negative 4, negative 4. Row 1 is 1, 4, 1, 0. So we get 1, 0, negative 3, negative 4. Okay. So that's my new row 1. 1, 0, negative 3, negative 4, 0, 1, 1, 1. Okay, so here I've got the identity matrix on the left. It's in reduced row echelon form, and what that means is I've got my inverse on the right. Our inverse is the matrix negative 3, negative 4, 1, 1.